In this video, we're going to discuss how size of the nucleophilic atom can affect its nucleophilicity. So how good of a nucleophile is it? So in this case, we're comparing oxygen with sulfur. They're in the same column of the periodic table. Sulfur is below oxygen, and so sulfur is going to be that larger atom. When we draw out our transition states, we see that we have basically a similar look to the transition states we saw before for when we were comparing electronegativity. We have this extra group on our nucleophile, so we've drawn that out there. Our electrophile is exactly the same on both the transition states as well as the other examples that we were seeing. So we're looking at the nucleophile. We have this delta plus on an oxygen versus a sulfur atom. We've said that they're in the same column, and so we can say sulfur because it's below oxygen. Sulfur is larger than oxygen, so it's a larger atom. What that meant when we were talking about negative charges, it meant that it could stabilize negative charges better because we had more of that volume. Turns out but larger atoms can also stabilize positive charges better. The reason for this is that those electrons that are actually being shared are so far away from the nucleus that we don't have that kind of electrostatic kind of effect on that nucleus. The protons in the nucleus are far away from what those electrons are going to attack. And so we actually have the larger atoms like sulfur being able to handle that delta plus better. And so what that's going to mean, that transition state, so transition state B in this case, is going to be lower in energy. So that means we're going to have a lower activation energy, faster reaction, and that means because it's going to be a faster reaction that nucleophile is a better nucleophile. We also have other explanations that we can kind of say more generally, larger atoms are more polarizable. So that's kind of the term that we use to say that the larger atoms, when they're using those electrons that are super far out, those electrons that are super far out are actually more easily influenced by other atoms nuclei than electrons than they are of their own. So those electrons that are very far out on sulfur, for example, in that very outer shell, they're so far from their own nucleus that they're not feeling that positive charge that much from their own nucleus. But when they're starting to get close to a smaller atom, they can actually feel that positive charge a little bit more because they're so far away from their own nucleus. And that's what we call polarizable. So larger atoms are more polarizable than smaller atoms. And polarizable is that key term here that describes how easily influenced the electron density is by other species. So in general, we do see these larger atoms being better nucleophiles because they are more polarizable. So we could say that as well. In the transition state, we see that they're able to handle that delta plus better. Same kind of reason, these electrons are just so far out from its own nucleus that kind of electrostatic charge just isn't felt as much, and it doesn't have as big of an effect when those electrons are so far out. And so with those larger atoms, are able to handle that delta plus better. They're also, we could also say that they're more polarizable. So thinking about like right as the reaction's happening or right before the reaction's happening, those electrons in the outer sphere of the sulfur atom, they're actually able to be more easily influenced by that carbon's nucleus, the alpha carbon's nucleus, and are able to attack a little bit easier, faster than the oxygen atom or smaller atoms. For our reaction coordinate diagram, this would mean that the sulfur nucleophile is actually going to be the one taking the lower path this time. So lower energy transition state, we said that's going to make a lower activation energy compared to the oxygen, because sulfur is able to stabilize that delta plus better, that transition state as a whole, lower in energy. And so we're going to have a faster reaction. The sulfur is going to be the better nucleophile, or the larger atom. If we're thinking more generally, larger atoms are going to be better nucleophiles.